Hello, and welcome to another session of Dell Networking. My name is Homer Ahmed, and I'm a Senior Technical Marketing Engineer at Dell. In a prior video, I discussed and demonstrated convergence via FCoE on a Dell S5000 converged switch. In this video, I'll discuss and demo a converged solution employing the Dell S5000 switch and a Dell PowerEdge M1000e chassis with blade servers and Dell MXL blade switches. The Dell S5000 switch allows you to converge your LAN and SAN traffic, optimize and simplify your network for converged traffic with data center bridging, consolidate and minimize infrastructure hardware, and decrease IT management cost. Although I'll briefly discuss the end-to-end solution including the CNA, Dell PowerEdge server, Fibre Channel switch, and Dell Compellent Storage Array, I won't go into as much detail as this was covered in the prior Dell Networking S5000 FCoE configuration video. The prior video demonstrated the end-to-end solution with a Dell PowerEdge rack server. In this video, I'll cover configuration of the Dell S5000 switch in NPIV Proxy Gateway mode, configuration of the Dell MXL blade switches as FIP-snooping bridges or FCoE Transit switches, and multipathing from the server to the Compellent Storage Array. Once I'm done configuring the S5000 and MXL switches, I'll pass LAN and SAN traffic from the server to confirm successful configuration. For additional information, please make sure to check out the Dell S5000 white papers on Dell.com at the link below. Let's go ahead and get started. I made the network diagram the background of my desktop. It consists of a Dell PowerEdge M1000e chassis with a Dell PowerEdge M620 blade server with a 2-port Broadcom 57810 CNA, 2 MXL blade switches, 2 S5000 switches, and 2 Z9000 switches for my LAN core. I also have 2 Brocade 6505 Fibre Channel switches connecting to a Dell Compellent Fibre Channel Storage Array. The Dell Compellent Fibre Channel Storage Array consists of 2 SC8000 controllers and 1 SC220 storage enclosure. The yellow cables represent LAN connectivity and the purple cables represent Fibre Channel. The gray cables represent converged traffic. You can see here we have 2 fabrics. On the LAN side, this is all 10 gigabit Ethernet, and the SAN side, or the S5000 connecting to the Brocade Fibre Channel switches down to the Compellent Storage Array, is all 8 gigabit Fibre Channel. The Dell S5000 acts as an NPIV Proxy Gateway. NPIV provides FCoE FC bridging capability on the S5000. The FC switch used must also support NPIV. The Dell S5000 switch is connected to a FC switch and acts as an NPIV Proxy Gateway for respective end nodes. The PowerEdge M620 blade server is connected internally via a 10 gigabit Ethernet Broadcom 57810 CNA adapter to the MXL blade switch. The MXL blade switch is using both 40 gigabit Ethernet ports in quad mode and is part of a port channel to connect up to the Dell S5000 10 gigabit Ethernet ports. A 40 gigabit Ethernet QSFP Plus to 4x10 gigabit Ethernet breakout cable is used to connect the 40 gigabit Ethernet ports in quad mode on the MXL to the 10 gigabit Ethernet ports on the S5000. You can see that the Compellent Storage Array consists of 2 SC8000 controllers for redundancy purposes. Each FC switch has 2 paths to each controller. You can also see the LAN traffic is sent to the core Z9000 switches, which are employing VLT multipathing technology, down to the S5000s for a full non-blocked solution. Here I've set a virtual IP of 5.0.0.30/24. The Z9000 on the left is primary with the IP address of 5.0.0.10/24. Once I'm done configuring that Dell S5000 and MXL switches, I'll test the configuration by sending LAN and SAN traffic from the server. In this setup, I've already configured the Fabric B switches, so I'll demonstrate by configuring the Dell S5000 and MXL switch on Fabric A. Now that we understand the setup, let's jump on the S5000 switch and configure it first. So I'm on this first S5000 switch here, or the S5000 switch on Fabric A. And the first thing I'm going to do is configure the host name so I don't forget what switch I'm on. Next, I'm going to configure the switch for LAN traffic. Now, since the Dell Z9000 is a VLT coming down to the S5000, per VLT recommendation, I'm going to enable Rapid Spanning Tree Protocol, or RSTP. Now, here, because I'm using VLT, both of these links are still forwarding or non-blocking. The RSTP is enabled just as a precaution, especially when configuring the VLT. So let me go ahead and enable that first. Next, I'll put both of these interfaces, 40G048 and 40G060, in port channel 10. Port channel 10 is connecting up to the Z9000s. So I'll do 40G048 first. And I'll do the same thing for interface 40G060. Next, I'll go under that interface, port channel 10, and I'm going to put it in layer 2 mode with the switch port command. And the reason I'm doing that is because later I'm going to tag this port to the LAN VLAN. So next I'm going to enable the Fibre Channel functionality, and I'm going to do that with the feature FC command. And next I'll create the Dcb Map and configure priority-based flow control and enhanced transmission selection settings for LAN and SAN traffic. Priorities are mapped to priority groups using the priority-pgid command. In this example, priorities 0, 1, 2, 4, 5, 6, and 7 are mapped to priority group 0, and priority 3 is mapped to priority group 1. So let me go ahead and create the Dcb map, and I'll explain it along the way. I'm just going to call this SAN Dcb Map. And I'm going to use priority group 0 for my LAN traffic, and I'm going to give it a bandwidth of 60% with PFC off. For my FCoE traffic, I'm going to use priority group 1, and I'm going to give it a bandwidth of 40%, and I'm going to turn PFC on because I want lossless Ethernet for my FCoE. And then I'm going to use the priority pgid command, as I mentioned earlier, to do the mapping. So 1, 2, or actually 0, 1, 2, 3, 4, 5, 6, 7. So you can see here priority group 1 is mapped to priority 3, 0, 1, 2, 3, and on the S5000 switch, FCoE is always mapped to priority 3. And you can see here FCoE is given a bandwidth of 40% here. Priority 3 mapped to priority group 1 and 40% bandwidth. So now that that's done, I'm gonna create the port channel, go into the MXL, and apply the Dcb map to the respective interfaces. So the Dcb map is applied to all members of the port channel going to the MXL switch. It's not applied to the port channel, but actually the interfaces within the port channel. So let me go ahead and do that. First thing I'll do is create the port channel. And you can see on our diagram we're using 10 gig 012, 10 gig 019. So that's 8 10 gig interfaces. Oh, I see I made a mistake here. So you can see here, because of this is invalid input. I had to actually not put the command in right. Looks like I was probably missing a space. There we go. And now I'm going to go ahead and apply the Dcb map to all the interfaces in the port channel. And I'm going to use the Dcb Map command to do that. So next I'm going to go under the port channel I just created. And I'm going to put it in port mode hybrid mode. And the reason I'm doing that is so that port can carry both tagged and untagged traffic. You can see here the LAN traffic will be on VLAN 5 coming up to the S5000 over that port channel, and the FCoE traffic will be on VLAN 1000 too. Additionally, when the end node comes online, it logs into the fabric using the FIP protocol, and the FIP protocol communicates on the default VLAN, which is VLAN 1, and it must be untagged on the default VLAN. So this port channel interface should be tagged on VLAN 5, VLAN 1002, and untagged on the default VLAN. Therefore, I'm using the port mode hybrid command. I'm going to put this in layer 2 mode as well. And then I'm going to use the spanning tree RSTP edge port command. I'm going to make this port an edge port. The reason I'm doing that is because I have a single connection from the MXL switch to the S5000 and don't expect the MXL to participate in spanning tree. So I make this an edge port. Now I'm going to tag the port channel going to both the MXL up to the Z9000s on the LAN VLAN. So I have the LAN VLAN, which is VLAN 5, and I want to tag the VLAN 5 both on the port channel 12 coming up from the MXL and on the port channel 10 going up to the core Z9000 switches. So I'll first create the interface, or create the VLAN 5. Then I'll tag it on both of those port channels. Now I'll create the FCoE VLAN and FCoE map. The FCoE map is used to map FCoE traffic to the respective VLAN and interfaces. And I also apply the FCoE map to the respective interfaces here. So first I'll create the FCoE VLAN. And next I'll create the FCoE map. And I'll just name this SAN Fabric A. I'll link the FCoE map to the FCoE VLAN using the Fabric ID command. And next I'll set the FC Map. And I'll explain this command in a second. I'm gonna set it to 0EFC02, but actually you can set it to whatever. I'll show you the range here. This is actually defined by the standard. You can pick whatever value you want. If you don't pick a value, it'll automatically set it to the default of 0EFC00. I set it here to 0EFC02. So this FC map will be used as the first 24 bits of the FPMA or the fabric provided MAC address that will get assigned to the end node. The FPMA is a 48-bit address, and the remaining 24 bits get assigned by the fabric, or in this case the Brocade Fibre Channel switch. So the first 24 bits gets assigned by this FC map setting I'm using, and the second 24 bits will get assigned by the fabric or the Brocade Fibre Channel switch, and that's also known as the FCID. So the FC map plus the 24 bits of the FC map plus the 24 bits of the FCID equals the 48-bit FPMA MAC address that gets assigned to the end node. And that's why I set this FC map here. So now I'll go under the Fibre Channel interface. And I'll apply that FCoE map I just created. Alright, I went one step too far, or backwards. Let me go back into configuration mode. And I'm going to go under the port channel interface for my last step here, port channel 12. And I'm also going to apply the FCoE map here. So I applied the FCoE map to the Fibre Channel interface here, and also the port channel interface here going down to the MXL. And that's what really ties these two interfaces together here. You can see the FCoE map applied to both the Fibre Channel interface and the interface going to the MXL. Remember, the Dcb map was only applied on this port channel interface because it only applies to Ethernet. So let me finish applying the FCoE map to the port channel 12. And let me go ahead and save this configuration. Now that the S5000 configuration is complete, let's jump to the MXL blade configuration. The MXL blade switch will be used simply as a FCoE transit switch, passing the converged traffic straight up to the S5000 to handle appropriately. So now I'm on this Dell MXL switch connecting up to the S5000 I just configured. And the first thing I'm going to do is set the host name. Second, I'm going to enable DCB and the FIP-snooping feature. Now, this next command, service class dynamic.1p, is needed just so the switch will honor the .1p priorities. The next thing I'm going to do is I'm going to create the port channel connecting to the S5000 and set the appropriate DCB settings or DCB configurations. You can see here I'm using 10 gig 033 to 40. Remember, we set the 40 port 40 gig ports to 10 gig mode. Before the lab even started, this was set to quad mode. So I converted the two 40 gig ports to 8 10 gig ports, and I'm using a breakout cable to connect up to the S5000s. Oh, I forgot the range keyword here. Now that I've configured the port channel, I'm going to go under the LLDP settings, and I'm going to set this command, which I'll explain in a minute. So what this command is saying is the ETS recommended configuration TLVs will not be advertised, but instead will be negotiated. So we negotiated the DCB settings will be pushed down from the S5000 to the MXL, and the MXL will also push down the configuration to the CNA, and we just have to set these ports appropriately for that to occur. So we're going to set the DCBX port role to upstream, auto upstream. So this is saying set the DCBX, or we're setting the DCBX port role to receive a pure configuration, and the configuration source is selected from the auto upstream, and this is we're configuring this port channel 12 to be the auto upstream port. So the configuration will be received from the S5000 on this port, and we're going to configure this port connected to the CNA as a downstream port. We'll do that in just a minute. So let me do a no shut. And as soon as I do a no shut, you can see all the DCB negotiations, PFC, and ETS settings there. I'm going to go under that port channel 12, and I'm also going to set it to port mode hybrid, since it's also going to be carrying both tagged and untagged VLANs. Put it in layer 2 mode. And then I'm going to enter the FIP-snooping port mode FCF command. And this is basically saying configure the port for bridge to FCF links. Looks like I forgot some syntax there. So it's FIP-snooping port mode FCF. That port channel is connecting to our FCF, which is our Dell S5000 switch. Okay, so next what I need to do is configure the port connecting to the server CNA to push the DCB settings from the S5000 down to that CNA. So what I just did is I configured this port channel 12 is the upstream port to receive the configuration. I'm going to configure this 10 gigabit 09 port to push the configuration down to the CNA. I'm also going to set this to port mode hybrid. It's also going to be carrying multiple tagged VLANs and also the untagged VLAN for the default VLAN. I'm going to go under the LLDP settings, and I'm going to set the DCBX port role that we set earlier, except this time I'm going to set it to auto downstream. You'll remember on the port channel 12 we set it to auto upstream. Do a no shut, and here you can also see the DCBX negotiation occurring. And the last thing, well, almost the last thing I need to do is I need to create the LAN VLAN, which is VLAN 5, and tag both the interface going to the CNA and the interface port channel going up to the S5000 on it. And what I'll finish the FCoE configuration by putting the respective interfaces in the FCoE VLAN and enabling FIP-snooping on it. So let me create the FCoE VLAN 1002. Notice here I have to tag both the interface going to the CNA and the port channel interface going up to the S5000 on the FCoE VLAN. You'll remember when I configured S5000, I didn't have to tag the FCoE VLAN on any interface because as soon as I applied the FCoE map, it already tags that interface automatically on the FCoE VLAN. Here I have to set the FC map to what I had set it to on the S5000. If I don't set it to the same, it won't work. There'll be a mismatch. Now I wouldn't have to set this if I would have just left it at the default of 0E FC00. And next I'm going to enable FIP-snooping on this FCoE VLAN with that FIP-snooping enable command. And you can see as soon as I did that, it's a good sign a FIP-snooping session was created. And you can see here's the FCoE MAC. And notice here, the first 24 bits is the FC map we assigned on the S5000. Remember I said the first 24 bits will be the FC map? So this is the first 24 bits that we assigned for the FC map on the S5000, and the second 24 bits is the FC ID assigned by the fabric or the Brocade Fibre Channel switch. So this is just means domain 1, this is port 4 on the Fibre Channel switch. You can see port 4 here connecting to the S5000, and this is session 1 over the NPIV link. So the first session over that NPIV link. So one last thing I need to do on this is I need to configure uplink failure detection. I want to configure uplink failure detection because if the upstream connectivity from the MXL to the S5000 ever fails, then the 10 gig 09 interface here should go down so the CNA port can fail over appropriately. Right now I have this as active standby configuration, but I want this to fail over if I ever lose upstream connectivity. So in order to do that, I have to configure uplink failure detection. So let me do that really quickly here. Uplink state group 1, and then within that group I'm going to put both the upstream and downstream interfaces. Downstream is 10 gig 09 going to the CNA, and upstream is the port channel 12 going to the S5000. And then I put the downstream auto recover, which basically just says enable auto recovery of the disabled downstream port when the upstream port comes back up. And let me save this configuration. So if I do a show FIP-snooping enode, you can see the end node is logged into the fabric and here's its FC ID. I can do the show FIP-snooping sessions command to get a little bit more detail, and here you can actually see the FCF interface. Let me go to the S5000 for a minute. I can also run this, and you can see here on the S5000 it also shows when the FIP-snooping session was created. But on this S5000 I could also run that same command, show FIP-snooping enode, and you can see that the end node did log into the fabric. So that's it for both the S5000 configuration and the FCoE Transit configuration on the MXL. What I'm going to do now is I'm going to go to the server and pass some traffic to make sure that the configuration is actually working. Before I jump on the server, I should mention that the active standby only applies to the LAN traffic. The FCoE is still active, and because I'm using an MPIO policy of round robin, it's actually going to multipath over both of these links when I send storage traffic from the server to the Dell compellent storage array. So let me jump on the server and show you that. First, let me show you the MPIO policy. If I go to storage, disk management, and select my remote compellent storage, properties, and hardware, and then properties again, you can see under the MPIO tab it's set to round robin, so it will multipath over both of these links. Now if I set it to failover only, it would only use one fabric and use the other fabric upon failover, but I'm going to go ahead and just keep it at round robin. So on our diagram here, you can see I set a virtual IP of 5.0.0.30/24 using VRRP. I'm just going to go ahead and use one of these IPs assigned to one of these Dell Z9000s just to demonstrate LAN connectivity, and I'll use 5.0.0.10/24 assigned to this Z9000 on the left. So here you can see our LAN connectivity is good. Now I'm going to use IO meter to send test data to our Dell compellent storage array. Now I've already preset this up or pre-configured this prior. I have multiple threads here with different read-write rates, so I'm just going to go ahead and start this. And here you can see the IO meter is writing test data to our Dell compellent storage array. At the same time, we're pinging out to our Z9000 to demonstrate LAN connectivity. So I'll go ahead and minimize this, and what I'll do is pull up a console to each one of these Fibre Channel switches, both on Fabric A and Fabric B. This is the Fabric A Fibre Channel switch, and this is the Fabric B Fibre Channel switch. So I'll run this command to show the traffic coming in and going out on ports 3 and 10, or 3 through 10, sorry. So on this first diagram, or on this first Fibre Channel switch, you can see the traffic is coming in on port 4 and going out on port 3 and port 9. On the second Fibre Channel switch in Fabric B, you can see the same thing. The traffic's coming in on port 4 and going out on port 3 and 9. And I know that because my Dell S5000 switch is connected to the Fibre Channel switch on port 4, so the traffic's coming in on port 4, and you can see 3 and 9 are connected to the compelling array. So what we're seeing here is that both fabrics are being utilized to provide multipathing as well as failover capabilities. You can see on each Fibre Channel switch the traffic comes in on Fibre Channel port 4 and goes out on Fibre Channel ports 3 and 9. The reason for this is because ports 3 and 9 on each Fibre Channel switch connect to controller 0, which is the primary controller that owns the disk that is being written to. And you can see this on the diagram here. Port 3 and port 9 on this Fibre Channel switch on Fabric A goes to controller 0, and port 3 and port 9 on this Fibre Channel switch in Fabric B goes to controller 0. So that's it for this session of Dell Networking. Thanks for watching, and don't forget to check out the Dell Networking S5000 white papers.